Now we are going to do actual statistical hypothesis testing. First, we're going to do statistical hypothesis tests on one population parameter. So just to review, these are the two approaches and their different steps of a formal hypothesis test. Since one population parameter can still be done manually or by hand, we're first going to do that for the experience of it, and hence we're going to follow the critical value approach. Later on in future hypothesis tests, where you're going to use computers, we're going to use the p-value approach. So, if we're going to test one population parameter based on the sample data, we either test whether what we got is close to the population mean or close to the population proportion. Let's go first to the population mean. Now, if you want to know what's the population mean, and for some reason, even though you don't know the population mean, you have a value for the population standard deviation, which is usually possible in an industrial setting, then we can do this one population test for mean with known sigma, which is known as the one population z-test. Now, but before we go to that, we have to be sure that if we know the population standard deviation, we have to know whether the population is truly or at least approximately normally distributed. If it is, then we can proceed to our one population z-test. If it's not, we have to check if the sample size is greater than or equal to 30. If it does, then this will follow our central limit theorem, which states that as long as the sample size is large enough, then the sampling distribution will be approximately normal, and that's enough, even though the actual population is not truly or approximately normally distributed. However, if the sample size is smaller than 30, we cannot use one population z-test. So, we have to have the assumptions rather, that the sample is random and either n is equal to 30, so it's an either or situation. Either n is greater than or equal to 30, we're good to go. If it's less than 30, then we have to have that assumption that the population is normally distributed. The formula for the test statistic is very much similar to the formula for the z-score when we get from the sampling distribution. That's x bar minus the hypothesized value of the mean. The hypothesized value of the mean over sigma over square root of n. Very similar. Now, for the critical value and the rejection rule, our decision rule. Sometimes the rejection rule is also known as the decision rule. So, if it's one tail lower tail, the test statistic should be lower than negative z alpha, which we're going to demonstrate later. If it's one tail upper tail, then the test statistic should be greater than or equal to positive z alpha. Remember, alpha is our level of significance that the problem should give. In the event that it's two-tailed, then we either follow this or this, provided alpha has been divided into 2. So, let's have now a very specific example. So, we have number 1 here. A drug company claims that there is 10 milligrams of loratadine in their anti-allergy tablets. To test this, you got a random sample of 205 tablets from production and scientifically measured their loratadine content. You got a mean of 9.99 milligrams, and from the previous clinical trials, a standard deviation of 0.06. Can the claim of the company be justified at 0.01 level of significance? So let's write down the given. The claim is that there is 10 milligrams of loratadine. Since this is the claim, they are saying that the hypothesized mean is equal to 10 milligrams. Then we get a random sample of 205. Then the sample mean from the 205 is 9.99 milligrams. Then a standard deviation of 0.06 at alpha 0.01. Now, because n is equal to 0.05, n is already greater than or equal to 30, so that's why we can do z-test. This one population, z-test rather. One population, z-test. So, we know this is the claim. So therefore, for our step 1, which is writing the HO, the HA, and the direction, this becomes our HO, that the mean is equal to 10 milligrams. The population mean is actually equal to 10 milligrams. And since it's just equal to, the claim is just saying it's equal, doesn't say it's higher or it's lower, then the alternative hypothesis will be mean is not equal to 10 milligrams, making the direction a two-tailed test because it just says not equal. Now that we got that, we now compute our test statistic. So again, our formula for the test statistic would be the sample mean minus the hypothesized population mean over sigma over square root of n. In this case, we got our sample mean, which is 9.99, minus the hypothesized mean, which is 10, over the sigma of 0.6 over square root of 205. This will then give us, we can actually just use values up to 2 decimal places, but just to be safe, we'll also use values up to 4 decimal places. So what we're going to have would be negative 2.3863. So therefore, this is our test statistic. Z is equal to negative 3860. The next thing here now is we need to get our critical value. Our critical value will come from the Z table since this is a Z test. So the critical value that we need to get, since it's two-tailed, based from our decision rule, that would be Z is less than negative Z alpha over 2, or Z is greater than Z of alpha over 2. Which this is actually just the same absolute value. Since the normal distribution is symmetric, we just need to get alpha over 2 and get the z-score corresponding to that area. The given alpha is 0.01. So we divide it into 2. Therefore, we're going to get an alpha over 2 of 0.005. So now we need to go to the Z table and check which area has that has an area of 0.005. So wait a moment. Alright, so we have our Z table. Let's just zoom in. Now let's look for the negative because it's easier, for the one that has an area of 0.005. So this is here. This is 0051 and this is 0049. So therefore, since there's no exact 0050, we have to get the one in the middle. And that is from, that's negative 2.57 and negative 2.58. Hence, so this one would be from negative 2.57 plus negative 2.58 divided by 2. Therefore, the z of alpha over 2 would be positive or negative 2.575. So now that we got that from the z table, let's go back to our original solution. There you go. So our z alpha of z alpha over 2, which is z of 0.005 would be positive or negative 2.575. And now, for our decision, for the last step, our decision rule, since this is a two-tailed test, is that either z is less than less than negative z alpha over 2, or z is greater than z alpha over 2. Since the test statistic is negative, more or less will follow this one. So the question is negative 2.3863 greater than or less than negative, since this is negative here, negative 2.575. As we can see, negative 2.3836 is bigger than negative 2.575. So since it's bigger, we cannot follow the rejection rule, or because of this we have failed to reject our HO, because it wasn't able to follow the rejection rule. Hence, we have failed to reject our HO. Therefore, our conclusion would be as follows. Since we have failed to reject, the first sentence that we need to write is that there is no sufficient evidence to reject HO. Because the rejection rule serves as our evidence. The comparison of the test statistic and the critical value is the evidence. But since the test statistic is greater, we don't have enough sufficient evidence to reject HO. If the rejection rule was followed, we say there is. But since in this case it was not followed, we say there is no sufficient evidence to reject HO. Thus, or therefore, we then say that the claim of the company is justifiable, that the mean amount of loratadine is 10 milligrams. So that's one full-blown hypothesis test, where again the first thing you do, we state our HO, HA, and then the direction. We then compute the test statistic. We then get the z-score for the critical value. Then using the decision rule, we make the decision and then write the conclusion. Now let's go to number 2. A TV manufacturer claims that there are at least 2 televisions per household in the Philippines. A researcher agency drew a random sample of 1,200 respondents and asked about the number of televisions they own. The sample mean is 1.9 with a standard deviation of 0.08. Is there sufficient evidence to disprove the manufacturer's claim at 0.05 level of significance? So let's write it here. Alright, so in number 2, there was this claim that the average, there are at least 2 televisions per household in the Philippines. So on average, you would have 2. Let's take a look back. At least. So since it says at least from algebra means we have greater than or equal to 2. So it's claiming that each household would have at least 2 televisions per household. So now, a research agency drew a random sample of 1,200. And then they were the ones that were asked about the number of televisions that they own. The mean got from the sample is 1.9 with a standard deviation of 0.8. With alpha equals 0.05, would we have enough evidence to disprove the claim? So the first thing to do is we write HO, HA, and determine the direction. The claim says at least, and at least has equality, so that becomes null if the population mean is greater than or equal to 2. So therefore, therefore the counter to that is the opposite. The opposite of greater than or equal to is less than. Hence, the alternative hypothesis is the mean is less than 2. With that now in mind, since the the one for the alternative is less than, therefore the direction will be one tail, lower tail test. Now we go to computation of the test statistic. So based on our formula, that is x bar minus mu sub 0 over sigma over square root n, we're going to have 1.9 minus 2 over, this is 0.8 over the square root of 0, the square root of 1,200. There you go. So pause the video so that you'll be able to compute for this, giving it 4 decimal places. So after pausing the video, hopefully you're able to see that the value of this is negative 4.3301. This is now our test statistic. So the next thing to do now is to find our critical values. Find our critical values. Since this is one tail, lower tail, our decision rule would be z is less than z negative z alpha over 2. Sorry, not z alpha over 2, but z alpha over 2. So first we will need to find that negative z alpha, whose value alpha is 0.05. So we now go to our z table. Okay, we're now here at the z table, so let's look for an area of 0.05. This is already 0.0526 here. This is 0.05, while the other is 0.495. So I guess we can already use that. So based from the table, they came from negative 1.64 and negative 1.65. So therefore, based from that, oops, wait a minute. Alright, there you go. So based from that, we're going our z, negative z of 0.05 should be negative 1.65. We got the 1.65 by getting the average of this two. So there. So now going back, alright, so we get our negative z alpha as negative 1.64. So now for our decision, the decision rule is that z should be less than or equal to negative z alpha. So one tail lower tail test. So the z value we got is negative 4.3301. Is that bigger than or less than negative 1.64? So now as we can see, as we compare the two, negative 1.645 is bigger. So therefore, we now follow our decision rule, our rejection rule. And since we follow our decision or rejection rule, therefore, we have not failed, but we have rejected the null hypothesis. Therefore, we now conclude that since this is now reject, we now say there is a significant what do we call this? Not significant but sufficient, sorry. There is sufficient evidence to reject HO. Since we have rejected HO, thus we conclude that the mean is less than. So that is now the hypothesis test for number 2. So number 3 is left to you so that you can practice doing the 4 steps of hypothesis test. Perform a hypothesis test on number 3 and then let me know whether you have the answer or not. So that is the first of the different hypothesis tests on one population parameter, which is the one population z-test.